Hey there! Welcome to this episode! Today we're diving into one of those iconic architectural forms, the fabulous Flix Candela Shell. It looks pretty simple on the outside, right? Oh boy, once we dig into the modeling part, we discover all these different methods to create it. Each one gives us unique results and varying quality. In this video, we're going to explore a few different approaches step by step, from the super quick methods that get us results fast, to those that offer more control over the geometry. Throughout our journey, we'll check out the differences in outputs, the accuracy, the time needed, and the limitations of each method. By the end, we'll have a clear summary to wrap it all up. When it comes to modeling this form, which technique do you think is the best choice? If you're working with shell forms or just want to see how each method impacts the design process, this episode could really give you a fantastic comparison. Hey there, I'm Hussein and welcome to my YouTube channel. This video, it's the second part of our series called Different Ways to Model. You see, in each episode we dive into a specific architectural form and we explore different methods of modeling it. And at the end, we compare the differences, the accuracy, and the application of each technique. In this episode, we're going to tackle modeling a form known as the shell structure, or as it's famously called, the Candela shell. Now, this Candela shell is one of those thin concrete structures that are typically based on hyperbolic surfaces. And get this, even though they look all curvy and sleek, they can actually be shaped using just straight lines. This feature not only makes them structurally efficient, but also cost-effective in terms of construction. So these forms, they transfer loads in a membrane-like way, and with their thinness, they create a ton of stiffness, super useful for creating open spaces without columns. Because of these amazing properties, the Candela form is just a fantastic choice for exploring different modeling methods. In this video, we're going to try out a few different approaches step by step. We'll see what advantages or limitations each method has, and in the end, which technique delivers the best practical results. Let's dive in and check out the first method. For the first method, we start by drawing a star, like an 8-pointed star, just exactly how you see it on the screen, yeah? So I'm gonna click on the curve once to show the control points. If you're using older versions of Rhino and the control points don't pop up automatically, you can just hit F10. So now I'm gonna select the control points that I've highlighted here, and using the gumball, I'm going to move them upwards, to create that initial curve form. So after that, I'm picking the curve, right? And then I'm going to hit the rebuild command. In the point count section, I'm typing in 16 and then confirming it so the curve gets rebuilt and, gets a smoother division. Then I'm drawing a point right in the center, and just like you see in the picture, I'm shifting it a bit to get it just right for creating the shell. Next up, I'm selecting this curve along with the point we just made, and I'm going to execute the Loft command to get that shell surface going. Oh, and I'm adjusting the Loft mode to fit what I need, and the main surface is created. For adding thickness to this shell, I'm using the offset surface command, right? So I pick the surface, hit the command, and then I just plug in the thickness I want. The main body of the form is complete. Now, moving on to the next part. To create the side shell, I'm going to start by drawing a bigger sphere, and then I'll place a base surface right next to it, just like you see on the screen. So now I'm going to use the Boolean split command to slice the sphere, just to get that perfect part of the shell separated. And then I'm going to get rid of all the extra bits, keep the remaining part as the side glass. So far, we've got the overall shape of the shell. Next, we're going to add some finer details like drawing grids and lines on the glass, and a few tiny details here and there to really polish up. That's the first method where we modeled the shell using Loft. Now let's move on to the next technique. Okay, so let's dive into the second method for modeling the Candela shell. First things first, we start by drawing a curved member. You can create this member in various ways, but to keep this video from dragging on forever, I'm using the control point curve command to sketch out this curve. Now, alongside this curve, we need to identify a point as the center of our form. Just a little nudge here and there, and we position it so that the final shape of the shell gets closer to what we want, you know? Now we select the curve we created along with this point, and with the extrude to point command, we're generating a surface that converges towards that point. In the next step, we're going to take this member and we're going to use the array polar command and get this centered around that exact point we specified. So we're duplicating it like 8 times. And then at the end, we're going to join these surfaces together to create like one seamless page. It's going to be awesome. That's how we get the initial shell form, you know? From here on out, the process is kind of like what we did before. So to give it some thickness, I'm going to use the offset surface command. I select the page, execute the command, enter the thickness I want, and boom, the main surface thickens up just like that. After this, we're going to dive into creating the side shell, right? So just like before, I'm going to sketch out this big old sphere, and then I'm going to throw down a flat surface as the base. Then, using the Boolean split command, I'm going to slice that sphere with the flat surface, and then I'll just trim away all the extra bits. We only want what we need for those surrounding glass pieces, you know? And just like our first method, we'll have that overall shape all set. Then we'll add in some details and little touches, like we'll throw in a grid on the glass, some reinforcing lines, and a few other finishing touches that will just make the whole thing pop. So here we go with method 3, right? We're diving into the third method, the one where we actually use record history. So first up, you see this on the screen? Yeah, I'm going to draw a circle. Got it? Now, I select that circle and I run the rebuild command, setting the point count value to 16. You know, it gives us a much more uniform division, which is super important. Next, I'm selecting the circle again and using the divide command to break it into, you guessed it, 16 segments. It's all about that precision, right? And I just got to make sure that the start point matches one of the circle's control points. Seriously, we can't have the symmetry disturbed. That would be a disaster. Now I'm going to draw a line from the center of the circle to the diameter. And, you know, I use OSNAP to find the midpoint, right? And then, get this, I just delete that helper line because, honestly, we only need the midpoint. Next up, I'm going to create a control point curve with 2 points. One on that line we just marked, and another on the circumference of the circle. This curve, oh man, it's going to act like one of the shell members, you know? After that, I just get rid of that helper point because we really don't need it anymore. Now, I'm going to duplicate this spline using the array polar command, and I'm making 16 copies so that all the members are perfectly placed, just like in the picture. Moving on, since we don't really need the remaining points anymore, right? I'm going to hit the cell point command so that like all the points get selected, and then I'll just delete them, you know, just to keep things clean while working on the form. Now, I'm turning on record history, like super important. I'll select all the curves, and then I'll run the network surface command so Rhino can create a network surface based on these curves. I'll set up the selection filter so that like only the curves get selected and not the surface. This way it's way easier for me to control the geometry. I'm selecting the control points on the circle and the lines, right? And just like you see on the screen, I'm scaling them out a bit just to give it that wavy surface vibe. Then I'm pulling those points up a little to shape the final form of the shell. And honestly, with a bit of tweaking on those control points, as you can see, the final shape gets like way more complete. And then I just hide all the curves so the final surface looks super clean, right? From here, it's pretty much the same as before. To add thickness, I'm running the offset surface command, entering my desired thickness, and the shell gets its thickness. Next up, we're diving into the side shell construction. Just like before, I'm going to sketch out this massive sphere and a base plate. And then I'm using the Boolean split command to slice that sphere right along the plate. After that, I'm tossing out the extras and keeping what's left as the surrounding glass. So that totally wraps up the overall shape. And at the end, just like before, we'll sprinkle in a few tiny details like some mesh on the glass and surface lines, just to make the form more complete and, easier to read. So that's it for method 3. Up to this point, we've modeled the Candela shell using various techniques, right? Each method, it kind of covers a piece of the logic behind this form. Now I want to take those lines and curves we've created and whip up something totally different, a tensegrity form. This way, we can see how you can evolve from a basic geometry to more complex and unique structural shapes. But when it comes to these kinds of forms, manual methods just don't really cut it. That's when we need to grab some advanced tools like Enter Grasshopper. For building tensegrity forms, the pro way to go is to write an algorithm that controls the connections, forces, point arrangements, and the entire geometry generation cycle parametrically. With Grasshopper, right, it really boosts your modeling speed and you end up with this super precise and clean output. If you're into parametric modeling, I've got this course in my channel that starts from the absolute basics step by step. And if these kinds of forms excite you, I totally recommend checking out that course. It's going to be great. We've modeled the candle shell in 3 different ways, and we've totally explored the differences, the benefits, and the limitations of each method. So in the first approach, we crafted the shape manually using Loft. And wow, it was fascinating to see how we could adjust the shape by controlling the points. Then, in the second method, we utilized member duplication and array polar to create the form, which gave us way more control over symmetry and unity. Finally, in the third method, we went with record history and network surface to model the shape, and it was amazing to discover how changing the control points could allow us to tweak the final form faster and with more flexibility. We also threw in an example of tensegrity, right, just to show how you can get from these geometries to more complex structural forms. And then we pointed out that using Grasshopper is a more professional and precise way to handle these kinds of forms. It can really boost the speed, accuracy, and flexibility of your modeling. So these 3 methods, you now have a complete perspective on modeling these kinds of shapes. You can totally pick the method that works best for your needs. Hey, thanks so much for sticking with us all the way to the end of this video. If you really enjoyed these comparisons and modeling techniques, make sure to hit that like button and subscribe to the channel so you won't miss out on any future videos. If you've got any questions or thoughts about the methods we talked about, don't hesitate to drop them in the comments. I'm totally here to help, and I'll share even more insights with you. I really hope this video gives you a clearer perspective on modeling those complex forms and that you can use it in your own projects. Until next time, stay successful and full of energy.